Hello everyone. Welcome to today's lesson. On today's lesson we are going to talk about a very important concept in mathematics, and that's the method of least squares. So this is very important in the study of numerical analysis when you are studying the approximation theory, and also in the study of regression analysis when you are studying a simple linear regression model and the multiple regression model. So before we start, please do not forget to subscribe to our YouTube channel and please like the videos if they help you. So the method of least squares is a method that minimizes the sum of squared errors. So whenever you have something and you want to approximate it, we have the exact and we approximate it. So when you take the approximation from the exact, you realize that there will always be a certain figure, and that figure is the error. Because you are making an approximation, you're not going to get the same thing as the exact. So there will always be an error, and let's call it epsilon. So what our least square method does is that it tries to minimize the sum of the square root of our errors. Okay, so we'll get there. Right, so for instance, if you want to approximate a data with a linear function, then we approximate it with this particular polynomial here. So we can have an exponential function as we can see here, and you want to approximate that exponential function with a linear function here. Realize that this is a linear function, that's a polynomial of first order. So if you want to approximate this, then that means we need an a naught, so an a naught and an a1. So how do we find our a naught and our a1? That's the problem here. So now the question is, how do we find the formula for estimating a naught and a1? So this is when our method of least squares is employed. So the error is the exact minus the approximated, as I've said. So remember that we said our we are approximating it by a line. So it was given as p of x equals e naught plus e1 xi, right? That means our error is the exact, which is yi minus the approximated. So when you expand this, you have this equation here. But recall that the least square method reduces the sum of squared error. So that means we have to find the square root of our error and sum it. So that's what you can see here. So the square root of our error, then we sum them. So we get something like this. Then we take the partial derivative. So we move on to take something from multi-variable calculus, and that's partial derivatives. So we take the partial derivatives with respect to e naught and e1 and we equate them to 0. So when you take the partial derivative with respect to e naught here, you're going to end up with this that we have here, and we equate this to 0. So when you equate this to 0, you can divide through by 2. So that means this 2 goes away, and you have this particular equation here, and we name that equation 1. Then the second thing we do is that we differentiate the same thing with respect to a1 partially. So when we do that, we get this particular equation we have here, and we equate it to 0. So equating this to 0, we get this. When you divide through by -2, that means we have this, and we name this equation 2. So that means that we have these two equations. So this equation and that equation. The next thing we do is that we take the summation through. So when we take the summation through for equation 1, this will give a summation of yi, then summation of e naught, which is same as n e naught, because when you have summation I starting from 1 to 4 of 2, so what this thing means is that we are trying to add 2 4 times. So it is 2 plus 2 plus 2 plus 2. So this is the same as what 4 times 2, and here our n is 2, so it's the same as 2n. So that's why here we said n a naught, and we have this equals 0. And when it comes to the second equation too, we take the summation through, and we have these two equations. So from equation 1, we try to make n the subject. So making n the subject, we end up with, sorry, we try to make E naught the subject. So making E naught the subject, we end up with this. And you realize that this thing here is the same as the mean of y, and this thing here is the same as the mean of x. So, but note that y bar, which is the mean of y, is this, and x bar, which is the mean of x, is this. So that means that finally our E naught will be y bar minus E1 x bar. So this is the formula for estimating our E naught. But remember that it has an E1 here. So that means before we can estimate our E naught, we have to know what our E1 is. So now how do we get our E1? So now we have to find our E1. So from equation 2, we have this. You can check it. This is what we have for equation 2. We want to make E1 a subject. So we try to, make E1 come to the left hand side, anything containing E1. So we bring it here and we have this particular equation here. The next thing we do is that we have E naught here, but we have found our E naught to be y bar minus E1 x bar. Then we can make substitution. So when you make substitution, that means wherever we find our E1, we are going to E naught, we are going to put this there. So that's what you can see here. When we expand it, we get something like this. The next thing is that we try to bring all the terms containing E1 to the left hand side. So we have this. Then remember that our y bar here is this and our x bar here is this. So we can make substitution. So when we substitute them, this is going to be our x bar, this is our y bar. Then we multiply through. When we multiply through, this time this will give us summation of xi all squared over n. When we multiply through this through by this, you get summation of xi summation of yi. So the next thing is that we want to make E1 the subject. So that means we can, bring them out. So when you bring them out, we have this particular expression here equals the right hand side. So since you want to make E1 a subject, that means you can divide through by this particular expression we have here. And when you make the division, then we have this thing over here. So it will be the whole of this over the whole of this. So that's what we can see here. And mostly we call this the sum of our xy's and this the sum of our xx. So simply put, we see our E1 is equal to this over this. So note that this, we've just learned how to find our estimators, that's E naught and E1, using the method of least squares. And it is very important, especially in your regression course. You're really going to use this a lot. So right now we've been able to estimate our E1 and our E naught. So let's take an example to illustrate what we've done so far. So the example says you should consider the problem of estimating the values of the function. So this is an exponential function with a polynomial. So with this particular polynomial at the following points. So we have these points for our x's and this for our y. So you should know that we have 4 points here. So that means that our n is 4. And the next thing for us to do is to find our E1 and E naught so that you'll be able to get this particular polynomial here. So we have to find E naught, E1, and P1 of x. But remember that our E naught is giving us this particular expression that we can see here. So that means that to find our E naught, we need our y bar, s bar, and E1. But our E1 is giving us this particular formula we have here. So this. And this is the same as this, and this is the same as this. So that means we need these things to be able to find our respective things that we have to then we do our computation. So this is our x, this is our y. So this is the sum of our x is 6. The sum of our y's is 15. Then this is just a product of our x and y. So this time there's 0, this time there's 2. And after that we sum them, which we get 34. And this is just the square of our x's. So when you square this our x's here, then we get this. And the sum of which is 14. So that means that the sum of our x is 6, the sum of our yi's is 15, the sum of the product of them is 34, and the sum of xi squared is 14. So finding for the mean, y bar is summation yi over n, so 15 over 4, which is 3.75, and that of x bar also gives us this. So remember that our E1 is given as this expression here. So when you make substitution, then there's our xxy. So you remember we've already found this. So you found this to be 34, this to be 6, and this to be 15, all over n, which is 4. So we get our xxy to be 11.5. Then our xxs is given by this particular formula here. When you make in substitution of the values we had, we get it to be 5. So that means that our A1, which is given as this, will be 11.5 over 5, which is 2.3. That means now we have our E1, so we can find for our A0. But A0 is given by this particular expression we have here, and there's our Y bar, which we've already computed, and there's our X bar, which we've already computed. So that means that simply put, our E0 is Y bar minus E1 X bar, and our Y bar is 3.75 minus, so our E1 is 2.3, X bar is 1.5. When you do this computation, you end up with 0.3. That means that our E0 is 0.3 and our E1 is 2.3. So it means our first order polynomial, which will be used to approximate or estimate this particular exponential function, is 0.3 plus 2.3x. And there's it. So this is what the question wanted us to do. So in regression, it is very important because it helps you to predict, make predictions a lot. Well, thank you very much. This is the method of least squares, which is very useful for you in your numerical analysis course and your statistics course, spiral and regression analysis. I'm Boydo Kanrino, a third year student of mathematics here in UST. Please do not forget to subscribe to our YouTube channel, like our videos. Thank you very much.